Thank you, Michael, and thank you, the honored speakers of the privacy and law session. Before starting the next panel, I would like to share with you a less than 2 minutes video that's relevant exactly to the two panels that we just participate and going to hear in a minute.
Security lately, largely because of what happened to Sony. Companies and individuals are more concerned about the safety and privacy of their information than ever. President Obama has unveiled a number of new proposals this week to crack down on hackers, and he plans to address this in the State of the Union speech on Tuesday. And it's great that the government is working on this, but the truth of the matter is we need to do a better job of protecting ourselves. You know, the most popular password in the United States is password 123. And as long as that's the case, we're vulnerable. So today we sent a camera out on the Hollywood Boulevard to help people by asking them to tell us their password. And this is how that went.
We're talking about cybersecurity today and how safe people's passwords are. What is one of your online passwords currently?
It is my dog's name and the year I graduated from high school.
Oh, what kind of dog do you have?
I have a Chihuahua Papillon.
And what's its name?
Jameson.
Jameson. And where'd you go to school?
I went to school back in Greensburg, Pennsylvania.
What school?
Hempfield Area Senior High School.
Oh, when did you graduate?
In 2009.
Oh, great.
It's like my cat's name and then just like a random number.
Okay. Has you had this cat for a while?
Yeah, she's my childhood pet.
Aw. And what's her name?
Her name is Jolie.
Jolie. So like a password of yours would be Jolie and then a number.
Yeah.
Like number 1?
Like my birthday.
Oh, when is your birthday?
June 12th.
Oh, nice. And what year were you born?
95.
Oh, great. So Jolie, 6, 12, 95.
Yes.
Got it.
Great. Yes. So these are our challenges in the cyber arena, and it starts our second panel. The second session is going to focus on cryptography, and it's interesting that at the beginning, people claimed about 10, 15 years ago that all this cyber, there were people that claimed that all this cyber is kind of a trend, and there were two very serious things. One is cryptography, and the other is information assurance. And I think that today we don't have to continue this debate, and the cyber discipline is already starting to be really a kind of a discipline, of course an interdisciplinary one. But today we decided to dedicate a session to the pure cryptology part, and we have three very distinguished speakers in our session. And the first speaker will be our guest from abroad that joined us, Engin Kirda, who is a professor of computer science and engineering of Northeastern University in Boston, and the director of the Northwestern Information Assurance Institute. He is also a co-founder and a chief architect at Last Line company that specializes in advanced malware detection and defense. Engin's research has focused on malware analysis and detection, web application security, and automated vulnerability discovery and mitigation. Before I invite Engin, I would like to mention that the three aspects that we are going to see this morning about cryptology, we will be able to see that they are not the traditional topics that we were discussing 5 or 10 years ago, but they are relevant to mobile, to new technologies, and even other aspects that we'll share in a minute. So Engin Kirda, please.
Hi, everybody. It's a pleasure to be here. Thanks so much for the invitation. I'm actually from Northeastern University. There's this, often this mix-up. And the winter was actually very cold in Boston this year. That's why it's a great pleasure to be here, actually. So I'm going to be talking about BabelCrypt. I'm not a crypto person. I appreciate cryptography, but I'm more of a system security researcher. But because this is the encryption decryption session, I decided to talk about something that's more applied cryptography, and it addresses a problem that I think affects quite a number of people. So the talk is based on a paper that we published last year. So if you're interested in the details, just Google the title. You can download the paper. So there are implementation details in there. So briefly about myself, I'm actually here with two hats. One of them is academic, the other one is industrial. So I do work on system security topics ranging from advanced malware detection to things like web security. But I'm also the founder of Lastline. So if you're interested in talking on any of these topics, I'll be around, so happy to talk and to connect you on these topics. So the communication today, if you think about it, has actually changed quite dramatically, right? 10 years ago, we were sending email a lot. We're still doing that, but on top of that, we all have mobile phones, and on our mobile phones, we have these messaging applications, things like Facebook Messenger, WhatsApp, Skype, Signal. So a bunch of these applications are there, and we use them a lot every day. So WhatsApp is incredibly popular. I use it maybe 15 times a day, right? You can exchange pictures, documents. So that's one thing that sort of has changed, right? The problem is that there are privacy threats related to these applications, and one of them is intercepted communication, right? So now we're actually trusting third parties, companies, to make that communication more secure. And lately, some of these companies like WhatsApp have actually started announcing the fact that they are integrating encryption. So WhatsApp just released it globally a couple of weeks ago, maybe a month ago. So they say they're doing end-to-end encryption, which is great. Maybe they're doing a great job at that, but maybe they're not, right? So we don't really know. So there are applications, they provide some security, but it's not clear how much privacy they're actually providing. Another potential privacy threat is that malicious communication, the communication service provider might be malicious, and they might be very interested in looking into that communication, right? Which is something that is a potential privacy threat. Compromised accounts might be a problem as well. So if you're actually using Google Talk, everything that you chat is actually logged somewhere, and you can go in, you can log in, you can check your chats. You can deactivate that, but many people actually don't, right? So if your account gets compromised, people can go back and they can look at what you've been chatting. And finally, even though WhatsApp might be very well-intentioned, or there might be companies that are trying to do a good job, they might be using third-party code, and that third-party code, for example, the encryption libraries, might be malicious. Because source code isn't always available, we're not sure if that the encryption is actually sound or not. So these are all the privacy threats. So the key takeaways of my presentation will be that even if an app claims to provide privacy and encryption, the question is, can you actually trust it? And the answer is, you cannot, as long as, because if you don't have access to the source code, and you can check it yourself. That's why I'll be claiming that we need techniques that allow us to plug in our own encryption, or the encryption that we trust, into existing applications transparently. And with BabelCrypt, that's what we actually try to do. We try to come up with a technique that allows us to use encryption that we've implemented ourselves, and to use it on top of existing applications like WhatsApp or Facebook Messenger. So if you look at current applications and methods, there are a bunch of apps that you can download that actually do provide security. Signal is one of them that I think is probably doing a very good job. There's Chat Secure, Silent Text. So a bunch of applications actually provide end-to-end security. The problem is, if you want to use them, then you need to convince everyone to use them as well, right? So if your dad uses, WhatsApp, and you don't trust WhatsApp, you need to convince those people to switch to this new app so that everybody has the same level of security. So that is one of the challenges. Another challenge is that there are existing applications that people have proposed. This is a paper that was published at Using Security a couple of years ago called Mimesis Aegis. It's a good solution. The problem is every time you'd like to use this on top of an existing application, you need to do a lot of customizations. So we thought let's come up with a solution that works and that you can simply plug in on top of existing applications that provides the encryption that is then transparent to the user and that's transparent to the application as well. So BabelCrypt provides a solution to these threats with a generic and application transparent approach, and I'll be briefly talking about that. And it handles the encryption and the decryption at the user side, and it's invisible to the users, right? So the users have a higher degree of encryption, a higher degree of trust into the encryption, but they can use any application. So if a new application comes, let's call it chat, you can simply plug it on top of it, and it's invisible to chat and invisible to the users. The design goals, of course, is to ensure that the user experience does not change drastically. So whatever you do, you want to be able to allow people to use it. You know, it shouldn't be different than how they used to use, say, WhatsApp. And it should be invisible to the underlying chat application. So there can be encryption, but the app does not need to be aware of that. And it needs to be independent of the specifics of the underlying application. So whenever we wanted to do, we wanted to make it independent of the underlying application that you're using. If it's WhatsApp, then it cannot be WhatsApp specific, or the service provider. So here's a brief architecture of the entire solution. The idea is that every operating system, mobile operating system nowadays, allows you to bring your own keyboard, so you can actually have a customized keyboard. So we thought, let's take a keyboard, let's customize it, so it by default allows you to do encryption. So whatever you type is encrypted on the keyboard. It's then passed to the application transports it, and then you need a way of detecting that encrypted message and to decrypt it. So there's a component that runs in the background that actually checks your user interface using the Android accessibility framework. If it detects encrypted messages, it automatically decrypts them. And this entire process happens in the background transparently to the user. And by having this encrypted keyboard and this component that checks the displays, you're able to actually create something that's quite generic. Here's an example. If the user types "Hi Alice" on the special keyboard that we've created and types enter, this actually gets encrypted, right? So this is the encrypted text that the application would see, and the application and the service provider is not able to understand what you're typing. This then gets sent over the application, right? So these are the chats that you would see if you don't have BabelCrypt installed. The app would receive these, and transport these encrypted communication. And when the user actually reads the messages, they are automatically decrypted. So all this happens transparently to the user, and the user is able to see, the entire communication. But the application provider, and say WhatsApp, even if they have a bad encryption or they're able to look into the messages, would not be able to decrypt these messages. So on the left side, you would see what the app provider or WhatsApp or Viber would actually see, right? These are all the encrypted messages. On the right-hand side, you see that the keyboard has this color in the back. It's blue, it's red, which actually indicates that encryption is happening in the background. So we have some visual cues, and all this is actually done transparently and automatically. So the user just normally uses WhatsApp or whatever application they'd like to use. The encryption happens in the background, and they just see the decrypted messages displayed to them. So to design the system, of course, we wanted to have different options of encryption. The simplest form is to have a shared secret. It's very straightforward to implement. You and your friends might agree on a password to use. Maybe you agree by calling them. And when you type that password, all the encryption is done above the application that you're actually using. So it's very easy to implement. But to make it more usable, we also wanted to implement a key agreement protocol. So we wanted people not to have to choose a password. We wanted this to happen automatically because this actually provides better security, but it's more complex to implement because more messages need to be exchanged. And the question is, how do you actually do this over an existing application, say like Facebook Messenger? The solution is to register certain parts of the user interface if you'd like to do this, for example, where the send button is and where certain messages are being displayed, like the text fields. So you have to do this only once per application, and after you've done this, all the information message exchange is done in the background, transparently to the user, and the communication is encrypted and it's actually secure, so it becomes more private. So in more concrete terms, we actually implemented the Secure Communication Protocol, OTR, if you've heard of it. The nice thing about this is that it actually is now usable for all applications. Google Talk actually supports this, but to be able to use it on Google Talk, you have to use their very special API, right? So we've actually done something that sits on top and that can do this for arbitrary applications, which I think is an advantage. So, of course, we wanted to see if the usability is given, right? Is it something that people will be able to use? So we conducted some tests. We tested it on Facebook Messenger, WhatsApp, Skype, Tango, WeChat, Viber, so a bunch of popular applications out there, and actually worked without problems. So we thought, okay, this is actually good. This is working for existing systems. Then we did some performance tests, and the overhead was about 150 milliseconds on average, with some standard deviation, but it was not detrimental to the user experience. So people were able to use this, and they actually did not notice a delay. They said this is actually usable. So the tool is transparent, provides this privacy guarantee, and in terms of performance, it's actually doing well. We also conducted tests with about 40 users using Facebook Messenger. First, we allowed them to use the normal Facebook Messenger to exchange messages. Then we installed our system, and they interacted with one of our scientists at the other end, and we gave them an exit survey. So we wanted to find out, hey, is this fine? Do you have difficulties? Is it difficult to use? So we wanted to get some user feedback from users. So the results show that the simplicity is given, so people did not complain because it's actually transparent to them. They use it just like they're using WhatsApp or any other messaging service. The appearance and likability features were reported to be well above average, and they did not impact usability considerably. So we have quite a bit of trust that this is something that people could use out there once it's actually released. So there are limitations, of course. In theory, it is possible that the underlying application does not allow you to transmit certain characters, right? And if your encrypted messages are being transported via these applications, it might break just because you're not able to send some encrypted message. So this is not something we've seen, but for some apps, this might be possible. That's a potential. One disadvantage, usability disadvantage of a solution like this is that searching for chats does not work anymore because the app is not able to see your chats, right? So you can't use existing functionality, and you can't do things like spell checking. So if you want to do spell checking, you would have to do this in the keyboard, right? So the keyboard would have to provide this. For key exchange protocols, as I mentioned, if you want to do something more complicated, you need to register certain user interface components. You need to do this once, but if the UI changes, you would have to do it again. So this is not something we've seen a lot. So it's not like WhatsApp changes its user interface all the time, but if it does, then our tool would need to be re-registered. And we are not supporting pictures and videos yet. This is, I think, a big limitation, something that we'd like to work on, because people do exchange pictures and sensitive information quite a bit. So the key takeaways of the presentation, once again, even if an app claims to provide privacy and encryption, like WhatsApp is doing right now, the question is, it's great, I love the fact that they're doing it, but can you trust it? And you don't have the source code, you don't know how they implemented it, so I'm not sure if you can trust it. I think we need techniques that allow us to plug in our own encryption or whatever encryption you like to use on popular applications transparently. And this was our attempt to try to address that problem. I think it's a step in the right direction. There's still remaining work, but in terms of research, I'm going to mention one thing that I think is promising that could have actually quite a bit of impact. So the conclusion, BabelCrypt is a system that transparently protects the privacy of users. It can work with arbitrary security protocols without disturbing the user. So we implemented something that's quite transparent, runs in the background, enhances privacy. I think for future work, one really interesting research topic is if you take audio services and video services like Skype video and Hangouts, and if you're able to do something like this on top of that, that could be very interesting for a lot of people, because people do use Skype. There is encryption there, but can you trust it? That's one question that people always ask themselves. And if you can put something on top of that, but that allows you to use these existing applications, I think it would be very, very valuable. So with that, my 15 minutes are up, and I'll be happy to talk to you afterwards if you have any questions. Thank you very much. Okay. I think there's time for one question if anybody would like to ask a question. Yes. Oh, you mean like what WhatsApp is doing today, where you can use your desktop, or Signal? So it depends how they implemented it. So when we did this, we didn't think about that. That adds, a bit of a more complicated scenario. So we don't support that. So if you're actually doing that on the desktop client, you would actually see all the encrypted communication, so you wouldn't be able to read it. But it should be easy to write a desktop client for BabelCrypt as well that would decrypt it for you. So I think it's just an implementation issue in this case. Another quick question? Good question. So the question is, what would happen if the user doesn't have our tool installed, right? In this scenario, you would just see encrypted messages if the other person is sending you things, right? So you would need to coordinate with the other person. So, we just say, hey, let's use this tool, everybody installs it. At that point, it becomes transparent. But you're right. If they haven't installed it, then they wouldn't see it, but the application provider would also not see it. Thank you.
Thank you very much.